This is standard 8GA5. We're going to use informal arguments to establish some facts. Some of the first ones are going to be the angle sum and exterior angles of triangles, but we're going to skip over that one, and we're going to go to the second one. We're also going to establish facts about angles created when parallel lines are intersected by a transversal. And finally, we're going to establish some facts about angle-angle criterion for a similarity of triangles. We're going to start with B here because we need B to do A. Now we're using informal arguments to establish facts about angles created when parallel lines are intersected by a transversal. First off, let's look at what we have here. And let's make sure I got a pen that I want. We have got two lines here that are parallel. In fact, I'm going to put a parallel symbol. Whenever you've got these little arrows on it, these arrows match up. It means these two lines are parallel. Now, when we've got parallel lines and we have a line that crosses them, this line is called the transversal. This should be a review of something that you had learned years ago or a year or so ago, but we're going to review. That's the transversal. Parallel lines, transversal. Now, the interesting thing about parallel lines and transversals is when you've got parallel lines intersected by a transversal, you wind up with angle relationships that can help you understand what the measures will be. First off, let's talk about exterior angles. Exterior angles would be those that are outside the two parallel lines. If you look at this line here and this line here, those that are outside it, the ones on the outside, 1 and 2, 7 and 8 are our exterior. Angle 1, angle 2, angle 7, angle 8. Those are our exterior angles because they're outside the two parallel lines. Now, how about the interior angles? The interior angles would be inside the two parallel lines. In this case, angle 3, angle 4, angle 5, and angle 6. Now, these terms just help us when we're trying to name the angles. Now we're going to be more specific than just exterior and interior. We have what we call alternate interior angles, and let's name these. Alternate, T-E-R-N-A-T-E. Alternate interior angles. Alternate means on opposite sides of the transversal. So interior would be 3, 4, 5, and 6, just as we already said. Alternate are on opposite sides of the transversal. Angle 3 and angle 6 would be an alternate interior pair. They're on alternating sides of the transversal. Angle 4 and angle 5 are alternate interior angles. And if we use a translation, if we were to translate this down here and turn it around, rotate it around, you can do that with tracing paper. You would realize that angle 3 and angle 6 are congruent. They would map on top of each other. Angle 4 and angle 5, you would notice that they were congruent if you did that. Okay, so if we do that, see, if you took angle 3 and you brought it down here, you rotated it 90 degrees, you would put it right here on top of angle 6. Angle 4 and angle 5, same thing. So alternate interior angles are congruent. How about alternate exterior? Alternate means opposite sides of the transversal. Okay, so let's look at our alternate exterior angles. Exterior means outside, that's 1, 2, 7, and 8. Alternating sides, 1 and 8 would be an alternate exterior pair. Another exterior pair would be angle 2 and angle 7. Opposite sides of the transversal and outside, angle 2 and angle 7. Now think about this. If I were to bring this whole thing here, angle 1, this whole intersection down here, if I were to translate it down, angle 1 would be here. If I were to rotate it 180 degrees, that would put it on top of 8. Angle 1 and angle 8 would have the same measure. Those have the same measure. They would be translated on top, they would be rotated on top of each other, mapped on top of each other. Same thing we did here. We brought this down here and we rotated this. Where you have angle 3 here would wind up being on top of angle 6. They would be the same measure. Okay, that would be 180 degree rotation, moving it 180 degrees around. Okay, so we know about alternate interior angles, they're congruent. Angle 3 and angle 6 are congruent. Angle 5 and angle 4 are congruent. Alternate exteriors, angle 1 and angle 8 are congruent. Angle 7 and angle 2 are congruent. Now, the other one that we really need to know about right now are called corresponding angles. Corresponding angles are in the same relative location. If I think of this as one red light and this is another, if I could drag this down on top of this one, angle 1 and angle 5 would be in the same relative location. I could map them down. If I could translate this whole intersection down here, so this point is here, angle 1 and angle 5 would be on top of each other, mapped on top of each other. So they would be congruent. Oh, these were congruent too, if we didn't write that. Congruent. Angle 1 and angle 5 are congruent. They're in the same spot, upper left-hand corner. Angle 3 and angle 7 are congruent. Those could be mapped on top of each other with a translation. Those would be congruent. Angle 2 and angle 6 are a corresponding pair. They could be mapped on top of each other if I just took this whole thing here and translate it down. So they would be congruent. Angle 4 and angle 8 would be congruent. Now, interesting thing is, when you've got a situation like that, if you have one angle measure in here, you would know what all of them were. Let's say this angle here was 60 degrees. These two would form a linear pair. They form a straight angle together. So they would be 180 degrees together. 180 minus 60 would give me 120 degrees for this angle right here. Now, these two angles are vertical angles across from each other, so they are equal. This would be 120 degrees. These two are vertical, they're across from each other, so this would be 60 degrees. 3 and 6, like we said before, are alternate interior, so they have the same measure. This would be 60 degrees. These two are vertical, so 7 would be 60 degrees. These two form a linear pair. They form a straight line, so they add up to 180. 180 minus 60 is 120. These two are vertical. They're across from each other, so this one is 120. Notice the same thing that you have here, you have here. 120, 120, corresponding angles. 60, 60, corresponding angles. 120, 120, corresponding angles. 60, 60, corresponding angles. Now, what's going to be most important to us is this concept of alternate interior angles. We're about to talk about that over here. If you use informal arguments to establish facts about the angle sum and exterior angles and triangles, let's start with this. We're going to start with the sum of interior angles in a triangle. Let's say we have this triangle right here, a 30, 60, 90 triangle. And I want to prove that the three angles in a triangle add up to 180. Well, you could just add them up to see if it does, but the three angles in any triangle add up to 180, and we know it for this reason. I could tear off these three angles and bring them over here. Take this 30-degree angle and move it right there. Take this 60-degree angle, flip it over, and move it right here. Take this 90-degree angle and flip it around and put it right there. And if I put those three angles together, the 30, 60, 90, I wind up forming a straight line here, a straight angle. 30 plus 60 plus 90 is 180. That's a straight angle. I can prove that the three angles of any triangle, no matter what their measures are, equal 180 by tearing off the corners and lining them up to see if I can't make a straight line, a straight angle. Another way to prove that the sum of the angles in a triangle is 180 is by using two parallel lines. Remember how we had two parallel lines earlier? Okay. Well, here we've got L and K are parallel. Right here, these three form a straight angle, just like we talked about up here, a straight line. Okay. If you've got a straight angle, that means these two angles that make it up are going to add up to 180. The measure of angle 4 plus the measure of angle 1 plus the measure of angle 5 is going to equal to 180 because they form a straight angle. Together they form a straight angle. But I want to prove that, here's what I want to prove. I want to prove that the three angles in the triangle add up to 180. I want to prove that the measure of angle 2 plus the measure of angle 1 plus the measure of angle 3 equals 180. That's not what this says up here. It says these three add up to 180. Is there any way I can replace 4 with angle 2? Is there any way I'd know they were equal? Well, let's look here. Angle 4. We've got two parallel lines, and we have this transversal that runs right there, don't we? Wouldn't that mean angle 4 and angle 2 are alternate interior angles? They would be congruent. So I know that the measure of angle 4 is equal to the measure of angle 2. Why? Because they're alternate interior angles formed when two parallel lines are intersected by transversal, right? So I'm going to be able to put this 2 where this 4 is in a minute. I'm still have 5 here and I need 3. Angle 3, is there anything that would tell me angle 5 and angle 3 are congruent? Let's go to a different color so we can see our line here. We've got our two parallel lines, and here is a line that's a transversal because it crosses the two parallel lines. Look at angle 5 and angle 3. Aren't angle 5 and angle 3 alternate interior angles? Well, if they are, then, let's go back to our red pen. The measure of angle 5 is equal to the measure of angle 3. Same reason, they're alternate interior angles, right? Well, if that's the case, can't I substitute in place of this angle 4, measure of angle 4, measure of angle 2? And in place of this angle 5, can't I substitute in measure of angle 3? If I do that, now I've got exactly what I needed. The measure of angle 2 plus the measure of angle 1 plus the measure of angle 3 equals 180. All I did was substitute, right? And now I've proven that angles 2, the sum of angle 2, angle 1, and angle 3 equals 180 degrees by using these alternate interior angles and a straight angle. How about the exterior angles in a triangle? Angle 4 is an exterior angle. Angle 1, 2, and 3 are interiors because they're inside. Angle 4 is an exterior angle. Now, I want to show you something about this exterior angle. I know these three have to add up to 180, right? The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. How do I know that? Because those are the interior angles of a triangle, right? Interior angles of a triangle. Interior angles of a triangle add up to 180. Look at angle 3 and 4. Don't they form a straight angle right there? Wouldn't that tell me that those two would add up to 180? Then the measure of angle 3 plus the measure of angle 4 equals 180. Both of those equal 180, don't they? Well, if they both equal 180, can't I substitute this whole thing here, since it equals 180, in place of that 180? Then the measure of angle 3 plus the measure of angle 4 would be equal to the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. Now look at this. I've got measure of angle 3 on both sides of this equal sign, don't I? Can I subtract that from both sides and it won't change anything? I can. Now this says that the measure of angle 4, this exterior angle, is equal to, see, this is gone, measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. This exterior angle, its measure, is equal to the sum of the two remote interior angles. The measure of the exterior angle equals the sum of the two remote interior angles. Remote means away from, right? Think about it. When you have a remote from a TV, doesn't that mean you're away from the TV? So you're away from this angle here. You're not touching this exterior angle. 1 and 2 are both remote interiors. They're inside the triangle. They're remote from this exterior. So the measure of this the measure of this exterior angle is equal to the sum of the two remote interior angles. Let's check that up here where I think we had one. If I had an exterior angle over here and I was looking for its measure, if I added up 90 and 60, that would give me 150. I know these two add up to 180, so if I had 180 minus 30, it would give me 150. So I could get the measure of the exterior angle either way. Now, let's look at the one other thing we have with this particular thing. And in this, we're going to use informal arguments to establish facts about the angle-angle criteria for similarity of triangles. If we've got two triangles that are similar, then we know that their corresponding sides will be proportional. In this case, 4 is to 8, as 6 is to 12, as 8 is to 16. If I've got that, then I would wind up having, if I reduce that, that says 1/2 is equal to 1/2 is equal to 1/2. This tells me that all of these are proportional. Notice the angles, the corresponding angles, have the same measures. Well, if I know the three angles add up to 180, I only need to know that 2 of the angles are congruent to know the third one is. If I knew I had 104 and 104 were the same, and 47 and 47 were the same, then it would be easy enough for me to figure out that if you add those up, you get 147, and 180 minus 147 would give me 29. It would have to be the same for each one of these. I only need to know that 2 of the corresponding angles are congruent. So let's look down here and select the set of triangles shown below that can be proven similar by angle-angle similarity. Okay, I've got 59 is the same for both of these, but I don't have the same measure on here. Let's add these two up since I know the three angles have to add up to 180. 59 and 37, and if I add those up, I come up with 96. Okay, the three angles have to add up to 180. So 180 minus 96 would give me 84. This angle here would be 84. Look, I've got two angles that are corresponding, two sets of angles that are corresponding. I can go through and figure it out. This would be 37. So these two I can prove similar by angle similarity. How about these two? I've got a set of angles here that are congruent. I need to find one of these other two. I know that these two have to add up to 180. So I add up 145 and I get 145. Now let's subtract 180 minus 145 and see what we get. Okay, if you borrow one here, 10 minus 5, 7 minus 4 is 3, that's 35. Okay, now I have two sets of angles that are congruent, so I can prove these similar by angle. You can prove two triangles similar only by finding two angles if you use angle similarity.